Good morning. A course material on CE 8602 Structural Analysis 2 by Professor Anand, Assistant Professor, Department of Civil Engineering, Roganik College of Engineering and Technology. So, here, Unit 5 Plastic Analysis Introduction, Static Indeterminate Axial Problems, Beams in Pure Bending, Plastic Moment of Resistance, Plastic Moment Modulus, Shape Factor and Load Factor, Plastic hinge and mechanism, upper and lower bond theorems, analysis of determinate beams and frames. Plastic analysis, a method of analysis in which the ultimate strength of the structure is computed by considering the conditions for which there are sufficient plastic hinges to transform the structure into a mechanism. Plastic section, a section capable of reaching and maintaining the full plastic moment until a plastic collapse mechanism is formed. Plastic hinge, a fully yielded cross section of a member which allows the member portions on either side to rotate under constant moment, that is plastic hinge at the midpoint. Next, shape factor is the ratio of plastic moment to yield moment. S is equal to mp by m. Load factor, a factor used to multiply a nominal load to obtain a part of the design load. Mechanism, structural system which has sufficient number of frictionless and plastic hinges to allow it to deform indefinitely under constant load. So this is the plastic analysis diagrams. First, the stages are there: elastic stage, yield stage, elastic to plastic stage, fully plastic, and strain hardened. So shape factor for common cross sections. The shapes are rectangle, circular solid, circular tube, triangle, I sections, diameter. So for that, the shape factor value is 1.5, 1.7 to 1.27, 2.34, 1.12, 1.22. So next, basic three theorems: kinematic theorem, static theorem, uniqueness theorem. Static theorem, that is lower bound theorem. If a structure is in equilibrium condition under the external load and applied moment does not exceed the plastic moment of resistance, M is equal to MP. Kinematic theorem, it is upper bound theorem. It states that for a structure subjected to a loading corresponding to any assumed collapse mechanism must be either greater than or equal to but cannot less than true collapse law. And uniqueness theorem, it is quite clear that if a structure satisfies the condition of both static and kinematic theorems, the collapse load obtained must be true and NQ. In other words, a MQ collapse load is obtained when the three conditions of static equilibrium, yield, and collapse mechanism are met. So this is the introduction of plastic analysis. Thank you.